Okay, so for logarithms, it's designed to solve problems like this one in a way. So let's say you pick a number. Let's pick a number. Let's say 55, just some number between 10 and 100. So 10 to the what power equals 55. In other words, our equation is 10 to the x power will equal 55. If I'd picked a number like 10 or 100, I would know the answer, 1 or 2 there. But I don't know what that power is. I mean, you'd have to keep it's somewhere like 10 to the power of, I don't know, 1.3 or something. Oh, no, more than that. So maybe 1.5. Whoops. Can I copy and paste correctly? 1.5 is 31. 1.6. 39. I gotta go higher, I guess, huh? This would take a while. 63, so it's less than 1.8. So I'm guessing it's okay, it's probably 1.7. It's more than 1.7. Okay, so now I'd have to go to the second digit. In other words, this is going to take me, 175, let's say. Oh, that's a little bit too high. Do you see? This would take me like, it would take me a long time actually. Too low. So it's more, maybe it's 1.74. Still higher than that. So it's now I know it's more than 1.74, but less than 1.75. So it's 1.74, I don't know, 5? Getting close. You see, it's going to be painstakingly hard to solve for this. We don't really have an algebra step to solve this. Like, what do? Divide by x? No, that doesn't really solve that equation. Divide by 10? There's no algebra we can use to solve. So we have to use something called logarithms to solve this problem. So we'll learn how to solve problems like this and get exact answers in a way, in terms of log at least. So this is the form that we'll use to do that. So first you have to be able to switch forms. So the big concept here is logarithm is equal to or is an exponent. So exponent form is y equals a to the x. Log form of the same problem, just a different form, would be log base a of y equals x. So the way I think about it is like the A is always down low. Do you see how that's like the base? So that's the base. The exponent is always up high. So the exponent is, in this case, actually is this. So this is the one I remember. A logarithm is an exponent. So the exponent's always on the other side of the equation. This guy is the exponent right there. The other number is the other number. So let me just show you a few examples what I mean. So if you want to change the form, we're going to change the form from either exponent to log or log to exponent. So if you're changing this one to exponent form, it'd be something to some power, equals some number here. So we're going to fill in the blank, so to speak, here. So I always start with the base. The base is down low, so the 4 is down low. So down low on this side of the equation is going to be a 4. Then I go to the exponent. According to our memory trick there, a logarithm is equal to an exponent. So this guy must be the exponent. So 2 is the exponent and must equal 16. That actually makes sense, right? 4 to the second power is 16. Okay, so it's kind of like, 4 to the power of that equals this other number right there. I'll just put this one in log form. So log base, I don't have a base there, of a number equals another number. So let's figure out what numbers to put where. So I start with the base. The base is down low, 2 is down low, so it's going to be log base 2. The exponent's always on the other side of the equation, so 3 has to go over here and 8 has to go here. So log base 2 of 8 must equal 3. There are some properties of logarithms. Let me make sure I got to everything there. Yeah, we did. Okay. There's some properties of exponents or logarithms that we can derive. So I haven't actually put the property, we're going to derive it. So I'm just going to say equals x here. Let's figure out what x is here in a second. So we figure it out. If you don't memorize these, it's actually kind of nice to memorize them once you figure it out. But just put it in exponent form. So it would be something to some power equals a number, and then we should be able to solve this problem. So This would be a is a to the power of the exponents on the other side, so a to the power of x equals 1. So we're trying to figure out what number we can plug in there for x that would always make that equal to 1. Well, you probably know, right? A to the 0 power, anything to the 0 power is 1, so this is going to be equal to 0. So the first property is the log of 1, it doesn't matter what the base is always going to be 0. Log of 1 is 0. If you memorize it, it's just faster. Could you derive it? Absolutely. But just faster to memorize. Okay, let's say equal to x. Let's change the form to figure out this property or law. So a number to some power equals a number. So a is the base, it's down low. The exponent's on the other side, so x is the exponent, and a is the other number. That's weird. So what number would I plug in there to make this work? So a to the what power would equal a. Well, a to the first power would equal that. So the property here is if the base and the number there match, so log 3 of 3, log 4 of 4, log 5 of 5, it's always going to be equal to 1. So that's the second property. These two are a little harder to derive. Just it's a little harder on the brain. You can do it, but it takes more thinking. So I almost recommend potentially memorizing these, but I'll show you kind of the way I memorize them, but in a minute. Let's just put a question mark. I didn't put x because there's already an x in the problem. So let's convert this to the form. And this should probably be, let's just change this. This should be log base a of a to the x. That should probably be in the parentheses technically for this. Okay, so there's an x up there. Okay, so this is going to be a number to some power equals some other number. So the base is a. The exponent's on the other side, so that's the question mark. A to the what power equals a to the x. And so we're going to figure out what goes in there for the question mark here. So what does go in there for the question mark? It would be a to what power equals a to the x. So this has to be x, right? So this is actually equal to x. Maybe I should have put x there, but we didn't know. So sorry, this equals to x right there. So that's the property. Log a of x equals x. The way I remember that sometimes is I just kind of think, like if I had this problem, let's say this was the problem. So let's say we had log base 3 of 3 to the 5th is equal to what? The way I might do this, I go, okay, I see like a smiley face there. Those kind of cancel out. You just get, oh, that's just 5. That's just the way I remember it. But you can derive it every time if you want to. But you'll see there's kind of a counterpart to this one in just a second. Okay, so let's try this one. So let's put this one. Oh, this is really weird. So this is why it's like extra hard on this one. This is actually an exponent form. I don't know if you see that, but I know there's a logarithm in there, but it's a number to a power equals another number. Well, that's exponent form. So let's put it into log form. So log of some base of a number equals some other number. Let's plug in what we know. The a, I would start with that. So that's the base is down low. The exponent's on the other side. Now the exponent's here, so on the other side of log it. So wow, this one, the exponent goes over here. So log base a of x. And this one is x. Okay, so this is the property. I went ahead and just wrote the full property because it was hard to derive. Okay, so this is the property. The way I remember it, like if I had a problem, let's say, let's do something like this. So log, actually, let me, right. So if I had a problem like 4 to the log base 4 of 3 equals what? So the way to remember this property, you go, well, that one's a smiley face. This is kind of a frowny face. Log base 4. If those both match, log base 4, the answer is just 3. According to the property, x is equal to x there. So it's just going to be 3. It just simplifies. If the base match, the key is the 4 and the 4 have to match, or the 5 and the 5 if it's 5 and 5. So those are the 4 properties of logarithms. Let's try to apply those. So these are actual problems. So can you apply those same 4 properties? Might be in a different order, but go ahead and stop the screencast and try to figure these out. So I'm going to kind of do them and just watch if you want. So the property is log base 3 of 3 is always going to be, what is that, 1 or 0? You got to think about it. So 3 to the what power is 3? That's going to be 1 every time. If you don't see that, you can pretend that's an x and you can set it up into exponent form. So 3 to the what power is equal to 3. X has to be 1 there. This one, 7 to the what power is 1, so 7 to the 0 power is 1. If you don't see it, you could put an exponent form. 7 to the x, I'll just put equals 1. 7 to the what power is 1, it's got to be 0 there. So the answer is 0. The answer is, the answer is 1 there. The answer is 0 there. This one, trying to figure out what that's equal to. I would just, kind of do this and go, okay, the answer is 9. But if you don't see that, you can do the property, you can put it into log form. So this would be log base 4 of a number, let's call it x, equals log the exponent, which is log base 4 of 9. So this must be equal to 9, if that makes sense. X and 9 must be equal, therefore it's 9. So that's a tougher one to derive. If you saw the shortcut, you go, oh, it's just frowny face, it's got to be 9 there, because those match. This one, we don't know it, so we could try to derive it. Let's try to. So this is going to be, I'll put it in exponent form, so 2 to some power, we just call it x, equals 2 to the third. And so x must equal 3. The other way to do it is smiley face. You see it. Oh, the answer is 3 there. Okay, there are 2 other things that are important. If you see a number without a base, so like see this one, it just says log of x, like where's the base? It doesn't seem to be there. Just like, do you remember with square root, sometimes we just write square root of 5, you've written square root of 5. We don't actually write the base of 2 or the index of 2 there because it's understood. Oh, it's square root. It's just understood to be 2. Oh, this is just a logarithm. It's so common. It's understood the base is 10 there. If there's no base and it's a log, it's base 10. So that's just the way we roll. We like to save a little bit of energy, and so not writing the 10 is just cooler to us. So if we wrote log of 7, the base is understood to be 10. Okay, this one is a special kind of logarithm called the natural logarithm. So remember the natural exponential function was e to the x. We learned about that the other day. So ln is a special kind of logarithm. So what's weird is, I don't know if we get that backwards as mathematicians. So ln stands for natural logarithm in reverse order there. So that is kind of weird, but that does mean log. So when you see ln of x, it means, oh, what's the base? It's understood to be e, and it's understood that ln is a natural log. So this is the same thing. Like this is what they mean when they say natural log of x. No self-respecting mathematician would write base e, but when they say natural log of x, it means the log base e of x. So it's a special base, which we kind of like. We like base e stuff sometimes. In fact, there's a button on your calculator. If you use the button on your calculator that says log, it's going to be this kind, base 10. If you use the natural log button on your calculator, that is going to be base e there. So it is something that will be helpful. So if you're trying to solve, all the properties we learned still apply to this one. So this is base 10. It's understood to be base 10. So this one would be, let's just say x. So this would be an exponent form. 10 to the what power is equal to 100. And 10 to what power? So x must equal, this must equal 2, right? 10 to the second power is 100. So writing the base there really does help us think it through and solve a problem like that to solve. Okay, so this one, oh, wow, that's weird, isn't it? It helps to write the base in there. There's a little base of e right there. I don't know if you see the bases match. So I see a frowny face, so the answer must be 3. If you don't see that, I guess you could put this into log form. You could say log base e. Wow, that's weird to write log base e. I should have written natural log, but I'm just writing it so in case you don't know what you're doing. So log base e of a number equals the exponent. So this would be natural log of 3. And what number goes in there? Natural log of 3, that's base e. Oh, that's just a 3 right there. That's the number that goes in there. So 3 would be the answer there. Again, natural log of 3 and log base e of 3 is the same thing. It's just a different way of writing things. I want to go back to the first problem we had. So this one. So if you want to solve this one, right, we could put it into log form, right? So we could say log base 10 of a number, 55 in this case, equals the exponent x. So if we had just typed into our calculator, log, so where's the log key? Above 10 to the x. So log base 10 of 55. I'm going to put a decimal in there just because I want a decimal answer, is 1.74036. Remember, we have trouble getting that. I knew it was 1.74. In fact, you could see more digits if you mouse up and press enter. But still, the exact value of that x value would be log base 10 of 55. So that's the exact value. You can use this. Back in the day, they used to use what are called log tables to do this problem. But now we just have the calculator to do that kind of stuff, which is actually kind of handy. Let's close with the PSAT problem. Go to stop and try it. Would yield exponential growth. So 2% of the initial savings is going to be, put $100 in, that'd be $2 every year. That's the same amount. This would be $1.50 every year if you put in $100. This is adding the same amount every year. It's got to be this one because the current value, this is getting compound interest. You're getting 1% of whatever the current value is. So after you start $100, add $1. The next year, you're going to get 1% of $101, right? So it's going to keep going up and up and up. That's interest on top of interest. That's the way our money grows. That is exponential growth right there. Have a good day.